Scientists are searching for life beyond Earth and have targeted 3 moons as potential location for their discovery. These moons have liquid water beneath their surfaces, a source of energy, and the perfect combination of elements like carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur, the building blocks of life. But what makes these moons so special? Why is liquid water necessary for life? Could these moons really harbor extraterrestrial life? Europa is one of the most fascinating objects in our solar system, and for good reason. This Galilean moon of Jupiter is the 6th largest moon, roughly the same size as Earth's moon. But what sets Europa apart is its unique composition of silicate rock and water ice, and the possibility of a subsurface ocean containing more water than all of Earth's oceans combined. As we take a closer look at Europa's surface, we're struck by its diverse landscape characterized by a vast network of cracks and ridges, with the most notable feature being the Europa Lineae, a series of linear cracks that run across the entire moon. These cracks are believed to be caused by the powerful gravitational pull of Jupiter. The surface of Europa is also covered in ice, constantly reshaped by geological activity including subsurface oceans and Jupiter's gravitational pull. And that's just the surface. Beneath the ice lies the real intrigue. Europa's subsurface ocean is considered one of the most likely places in our solar system to contain life, with the necessary conditions such as liquid water, organic compounds, and energy. The existence of this ocean is supported by evidence of a strong magnetic field and plumes of water vapor erupting from the surface. Recent findings from the Galileo spacecraft even suggest that water plumes may be venting into space from Europa's surface, potentially providing a source of material for life forms in the ocean to interact with and exchange genetic material with other life forms in the universe. The strong magnetic field and presence of heat-producing isotopes in the subsurface also add to the potential for life to evolve in this saltwater ocean. The upcoming Europa Clipper mission will be a major step in our search for life on this moon, as it will study the subsurface ocean and search for signs of life. The potential for life on Europa is one of the most intriguing questions in planetary science, and the answers we seek are just a mission away. Enceladus is a small but mighty moon that orbits Saturn. With a diameter of just over 500 kilometers, it may be small compared to other moons, but it's a huge deal in the scientific world. This moon was first discovered in 1789 by astronomer William Herschel, but it wasn't until the Cassini spacecraft arrived in 2004 that the true potential of Enceladus was revealed. What Cassini found was a young and active surface with a network of cracks and fissures, from which water and other materials are expelled in the form of geysers. These geysers, which contain water vapor, ice particles, and organic compounds, have made Enceladus one of the top candidates for the presence of life beyond Earth. Enceladus has a unique and fascinating geology that sets it apart from other objects in the Saturnian system. Its surface is young and active, with a network of cracks and fissures that are the source of its famous geysers. The heat generated by tidal forces as Enceladus orbits Saturn creates a subsurface ocean of liquid water, which rises to the surface and eventually expelled into space as the geysers. This subsurface ocean could provide a habitat for life to thrive. The moon also has a smooth, heavily cratered surface, which suggests that it has undergone a significant resurfacing event in its recent history. The search for life on Enceladus has been a major focus of scientific study since the discovery of its geysers. The key factors that make Enceladus a prime target for the search for life is the presence of liquid water and organic compounds in its geysers. These suggest that there is a source of energy and nutrients that could support life. Scientists have used data from the Cassini spacecraft, as well as computer models and laboratory experiments, to study the potential for life on Enceladus. In the future, a dedicated mission to Enceladus may be launched to further investigate the potential for life. Such a mission could carry instruments to directly sample the geysers and search for signs of life. Jupiter's largest moon and a true gem of the solar system. First spotted by Galilei Galilei in 1610, Ganymede is one of the Galilean moons. With a diameter of 5,268 kilometers, it's the biggest moon in the solar system and the only one with its own magnetic field, similar in strength to Mercury. Ganymede boasts a fascinating surface, dotted with impact craters, valleys, and mountains. The moon's composition is a mix of rock and ice, and it even has a thin atmosphere made mostly of oxygen, making it the only moon with an oxygen atmosphere in the solar system. This, along with the magnetic field, suggests the presence of a subsurface ocean that could potentially harbor life. We've explored Ganymede through various missions and probes, including the groundbreaking Galileo spacecraft, which flew by the moon in 1996. The data gathered from these missions has helped us better understand the moon's geology, magnetic field, and composition, including the possibility of a subsurface ocean. Ganymede's geology is both complex and captivating, with a rich history of impact cratering, tectonic activity, and surface modification. Its surface is primarily made of ice and rock, with silicates like olivine and pyroxene present. The moon's impact craters, ranging from small to large, give us insight into its history of collisions with asteroids and comets. Tectonic activity has also shaped the moon, with large ridges and valleys thought to have formed from the expansion and contraction of its ice shell. The bright and dark regions on the moon's surface are believed to be a result of various processes, including impact cratering, tectonic activity, and resurfacing. Ganymede continues to be a subject of ongoing exploration, with missions and probes sent to gather data about the moon's features and potential for life. The presence of a subsurface ocean, magnetic field, and organic compounds make Ganymede one of the most promising places to search for life in our solar system. The ocean is believed to be 100 kilometers deep and in contact with the moon's rocky mantle, providing the necessary ingredients for life. The magnetic field protects the moon from harmful solar radiation, creating a safe environment for life to thrive. Ready for some more amazing content? Then don't forget to give this video a big thumbs up and hit that subscribe button. By doing so, you'll be the first to know about all of our exciting new videos. Trust us, you won't want to miss a single one.